Good afternoon and welcome to today's webcast, Facilitating Lean with Synchronized Planning and Scheduling, sponsored by Dassault Systems. My name is John Hitch, Senior Technology Writer with Industry Week. Before we begin, let me explain how you can participate in today's presentation. First, if the slides and audio are not responding, press the F5 key to refresh the webinar console. The toolbar at the bottom of your screen includes a help icon if you require further assistance. We welcome your questions during today's event. To submit your question to today's presenters, simply type into the Q&A window on the left side of your screen and then hit the Submit button. We'll be answering as many questions as possible during the Q&A that will follow the main presentation. Today's session is being recorded and will be available on the Industry Week website within the next week for you to review. You'll be notified by email when the archive is available. On your console, the Dassault Systems logo is hot linked. If you want to visit their website during this webcast, you can click on a logo and a new window will open. This won't take you out of the webinar. Now I'd like to welcome our presenter. Tom Muth is the DELMIA Industry Director with Dassault Systems. Tom, a graduate of the University of Wisconsin, has over 20 years of experience working with manufacturing operations management and ERP solutions, serving a wide range of industries. Tom, the floor is yours.
Okay, thank you very much and welcome everyone to today's webinar, Facilitating Lean with Synchronized Planning and Scheduling. In today's webinar, we're going to talk about some of the lean techniques and how they are impacted by an advanced planning and scheduling tool, and specifically go through some background on some of the challenges that you typically see in maybe your operations for planning and scheduling. Talk about some new approaches and the impact that it may have on your lean teams, and give a brief demonstration along with some examples of customers who have taken a new approach in their planning and scheduling. So with that, let me first start off by talking about Dassault Systems very shortly here, in which we talk about the 3D experience in manufacturing. 3D experience is the Dassault platform and applies in manufacturing. And what you're looking at here is a compass that represents the platform itself. At the very top, we focus on providing a collaborative management process and platform that really helping all stakeholders that are involved in operations to collaborate, whether it's planning and scheduling, whether it's design, whether it's operations management, and facilitating that across the different departments. The 3D button you see here is really about engineering. So engineering all industrial processes, focusing on eliminating time and waste. And this is what I would say would be the area of design and digital process simulation. The operate you see here, which is V+R, standing for virtual plus real, really takes now that simulation and brings it into the actual operations execution side of the manufacturing operations. So this really focuses on synchronizing your industrial operations with a focus on synchronization and driving efficiency. And then the last part you see here is optimize, which is really focused on supply chain and operations with dynamic scheduling and predictive analytics. In this case, this is going to be the focus of today's webinar. Now, as we've seen in the market from a source here with Aberdeen, best-in-class companies combine ERP, MES, and APS, Advanced Planning and Scheduling. And as you can see here by the charts, significant improvements are made with companies who have taken this type of approach, from on-time delivery to a shorter lead time to a shorter time to actually have finished goods inventory on hand. And the impact is quite dramatic by looking at this chart. And so we highly recommend companies take a broader view when they're looking at the planning and scheduling, and also consider the impact on how they change their operations and their lean programs inside their operations themselves. So we provide the ability to do dynamic planning and scheduling through digital continuity. So it's not detailed planning and rescheduling in a vacuum. It's really coordinating that with production, but then also coordinating that across maybe the engineering as well, within digital manufacturing, where you may be able to simulate processes before actually going into production and simulate schedules and put together scenarios to determine the best optimal approach for setting up a production line or doing a ramp up for new product introduction. I have a customer example I'll talk through at the end of this webinar that kind of highlight what we're talking about here as well. So what are some of the challenges? And a lot of these challenges, you probably have some, you may have all, or you may have some different ones. But I just threw up here a couple different challenges that we see overall in companies in their plant planning and scheduling. You know, whether it's being able to anticipate new product introduction and the ability to deliver to the forecast, whether it's being able to just meet customer demand to avoid either transportation costs or reduce penalties for misdelivery. As you can imagine, with the customization of production today, with the order of one and the trend in the industry across all industries, the amount of SKUs and packaging is really just increased dramatically. And there's really a continuous increase on that side as well. And then just how do you maximize some of the assets that you have, both labor and production, and compress the manufacturing cycle times. So a lot of these areas, these challenges are challenges that I know that your lean teams are trying to lean out as well. So planning and scheduling, the detailed planning and scheduling within the plant has a dramatic impact on your ability to have a lean operation and also to deliver on time in the most consistent, fast fashion. So let's just go back in history here a little bit and look at some of this digital transformation across plant planning and scheduling. As you can imagine, back in the mid-20th century, it was really done off of a board. And some companies are still doing that today on their plant floors, where they get the ERP order sent down and pushed, and then it becomes the role of the plant operations to sort out the best options for production and schedule the actual true operations for producing the product. As we went up, we continued with push manufacturing and using some static tools like MRP to support that as well. Again, very much not customer-centric, mostly a push level where it's assuming infinite capacity and driving the production down into the plant floor, regardless of the actual conditions of the plant operations, which has to then get rectified unfortunately, by the plant manager or a scheduler down within the plant itself. And then we got a little fancy out there and started to bring in concepts of lean, but then bringing in Excel and using Excel really as the APS. We've seen this tremendously out there in the market, and where companies that haven't adopted an APS really have relied on an in-house tool that is frankly just not collaborative, difficult to maintain, and difficult to move over some of the tribal knowledge when you take in consideration of personnel. And then what we're focusing on today is really a new approach, a more agile approach to deal with what we call the industrial renaissance. You may consider it smart factory or industry 4.0. But here we really want to take a new step and a leap towards a more agile and collaborative tool to help manage and transform operations with a detailed plant scheduling and rescheduling tool that accommodates, the needs that we have in today's marketplace. So let's talk about the plant planning and scheduling solutions that we're focused on here and get back to reality. As we said, the planning and scheduling from our experience in the marketplace is still done a lot of times with tools from the past. And some of the things you see here are things that would be negative in terms of using those types of tools, where it may be manual, may be time consuming, it's very static, it's not dynamic in nature, you're not able to get information fed back from the plant floor that may account for unplanned maintenance or unplanned downtime or unplanned labor constraints that may make your plan and schedule ineffective and really miss targets, whether it's delivery or whether it's inventory, etc. It's also expert dependent. As you can imagine, that creates a lot of risk. And so our focus today is really on helping you with a better approach through an advanced plant-centric planning and scheduling tool. So what we're going to show you a little bit later is areas that allow you to be more dynamic, collaborative within your scheduling and planning. Also to create a situation where we can automate and take information to optimize the schedule and plan from real-time data that's happening on the plant floor and use that to help optimize. So we have optimization that's part of that and simulation as well. And being able to do that allows us to do things like load capacity leveling. You may be able to do what-if simulations while you're in production or even before production, before you actually start a new product being produced on the plant floor. So all of those are really a better approach to the manual approach that I mentioned before. And one of the things just to ask the audience here right now is we have a quick question, if you can answer this, is what do you use today for your manufacturing and planning and scheduling solutions? Are you using ERP, MRP only still? Do you have a custom in-house scheduler? Do you already have an APS, or is your operations manual and Excel, using Excel? So I'll give you a couple seconds to fill that out and answer it. As I mentioned before, we're seeing a lot of companies across all industries, honestly, and different manufacturing styles that are kind of relying still on MRP or their ERP systems to drive the actual schedules down and do the detailed plant scheduling and planning. The issues that we see there beyond some of the things I brought up are things that are related really just to ineffective feedback to the plant, from the plant itself back into the scheduler that may be running the MRP or running their ERP schedule. So with an advanced tool with real-time feedback, that moves from maybe a weekly update to a daily or shift update so that you're responding quickly to a customer order. So we go beyond a push-based manufacturing style to really a pull-based, which is more customer-centric and also gives us the type of information we want. So let's see how we did here. As we expected, manual Excel, 54%. And many of you also have an in-house scheduler that's running it. So that kind of matches up actually with some of the findings we've been seeing, and I appreciate the feedback everybody gave here. So with that in mind, let's continue on. And let's talk about some of the considerations that you may want to think about for scheduling in a lean environment. As you know, the lean process, as you see here from a value here, there are several aspects that support the lean programs. Things that you may want to take in consideration when you're looking at the lean program and some of the aspects that are required to support it may be tack time. So for example here, we're talking about tack time now, but instead of tack time being done initially once, the tack time can now be updated based on schedule. So more realistic tack time can be developed, and we can focus on that now to level the schedule, in order to balance production and get us to a more consistent beat, as we call tack time. And make sure that resources are not overutilized or underutilized. and are focused on the proper resources that give us the best return. The other piece of it that it supports is your Kanban programs. So here we're able to use, reduced variability by using Kanban supermarkets or finish to order. So in this case, we're able to help the make to order strategies, which we see more common across all industries now, in order to help dampen the impact of all the fluctuation of orders that you might receive at the plant. So the simulation and modeling becomes an important aspect to support the Kanban program itself. And as we become more sophisticated, what's required in a lean environment is now the ability to model, to simulate, to optimize. This is where quantitative modeling techniques, especially for discrete event simulations, are important. So they're able to understand what the impact is going to be based on different changes that you may have within your plant or within your strategy or your product line, and be able to model and simulate that up front so that you're already leveled in your production plan before going to market as well. And then the last piece is collaboration, right? Having a tool that you can collaborate with your team, maybe your 5-minute standing meetings that you have for your each production shift, where you can highlight and understand how you've been managed on the production schedule itself, and not just leave the scheduling to the planner or to the scheduler, but then also bring in other stakeholders such as a plant manager or maybe even operators to help validate that schedule itself. And so by doing so, we now also have a way in which those events are captured and maintained, and you have a history. So we now have more detail that we could use to optimize in the future. So let's talk about, go through kind of an effective planning and scheduling scenario here. In this case, I'll be showing a tool that we have as part of Dassault Systems, which is DELMIA Ortums. This tool has been used across several different industries in particular, and has a wide breadth of customers and OEMs that have been using the tool overall to help improve their operations. But really what we're looking at with the solution here is helping you transform your plant planning and scheduling. And I talked about the modeling and simulation, and one of the key aspects of any advanced planning and scheduling tool is to make sure that you're able to do things like load leveling, you're able to do fine sequencing, and you're able to do flow synchronization. All of these are engines that make up the application, so that you really can focus on your goals within the plant. So whether you're doing capacity planning, whether you're doing mid or long-term planning from a master production schedule, or being able to now do different sequencing for different campaigns that you may have or new product introductions. Being able to have a finite schedule versus an infinite schedule, and also being able to synchronize at all the BOM levels that you may have. So being able to go deep into the synchronization, especially in an environment where you may have a very complex, discrete product that you're building versus a product that is more on a continuous flow. And of course, being able to maintain the order procedure and the build procedure as well, and capturing all those pieces. So as you can imagine, having a manual tool becomes difficult to maintain to cover all of these. And that's one of the reasons having an off-the-shelf solution helps tremendously today. So what are we trying to do? Really, we're trying to streamline the planning and scheduling processes, right? All of these areas that you see here really help support streamlining your lean operations and support your lean targets within the plant. So being able to do the constraints modeling, being able to look at constraints from a machine basis, maybe it's labor, maybe a critical supply, and then also look at things like bottlenecks, flow synchronization, and being able to do the what-if production scenario, right, and doing unlimited simulation there. So let's go through a little bit of a process here. And so this is what I would call an optimized process plan and schedule. On the top end, you see we're kind of running in an infinite capacity, assuming there's no constraints. And as we get down further and go around, we're getting more into a finite capacity planning. So as we start off, we're really defining the work plan. Initially, you would define that plan based on technical constraints and then link those resources to each of the operations that you have. From there, we're able then to go and start to set our capacity versus demand, balance the workload between the resources, and then analyze and simulate what the best outcome could be for my plan of the day or the week. By doing so, then we can use the information that's gained from that and monitored from a real-time basis, integrated with an MES system, to provide feedback, and then also to the dispatch board that the operators are running off of. And use the optimized schedule then each time and run that each time to enhance the operations itself. After that, there's always an option to enhance maybe your process planning and maybe even do that up front, where you may start off by just simulating and developing a plan itself, a plan of attack for your schedules for a new product, and then see, based off of some of the simulations, what the most optimal schedule and resource plan should be. So a lot of great things that come along this side here. And what I'm going to go through is just a couple pieces here, just a few areas here. So in one area here, we're talking about setting expected capacity versus demand, and then balancing the workload between resources. So in that case, what we're trying to accomplish here is knowing what to produce and in what quantity, right? So within the tool itself, you see here, there's different lines and different products, and also a flow of actual production orders. So here we're trying to understand what our material constraints are ahead of production versus reacting to that or assuming we have an infinite capacity. We're also now able to balance the workload with the labor constraints. So in many cases, you may have areas that are required certification for performing a task. Or there are certain experts that you need to have doing a quality check or maybe a machine operation. And in that case, you want to accommodate that within your planning and scheduling. In this tool, we actually support that, so you can understand where I'm going to have a bottleneck from a labor standpoint. I can do that also from a machine standpoint and be able to ensure that resources are available when they're needed, and also understand what those bottlenecks are going to be against the labor skills. We can then run a simulation to even that out based on labor availability or machine availability. So all of those are kind of naturally built in within the tool itself. Going forward, we want to balance the workload between resources as well. So we all have different machines and capacity that's available, and what we want to do here is level the machine capacity itself. Very much a lean activity in which you're trying to lean out your operations and ensure you're getting the maximum amount of effort being produced in the production environment itself. So here we're able to adjust the machine schedule to really improve service rates. So being able to, looking at this where, green is good, red is bad, yellow is caution, and being able to adjust my machine and production levels on the schedule to ensure I'm hitting on-time delivery. And by doing that, we're able to, here we're looking at, starting off maybe looking at how the plant is running, and you may find right off the bat that, you may are not as optimized as you could be. And here we're able to show bottlenecks through an infinite capacity model and run a simulation then to provide an optimized approach for production so that we've leveled off production to meet the demand, but also to level off the machine availability as well. So we're not overtaxing particular equipment or resources and maintaining a consistent flow. The other area that is very unique is an optimized engine. So here you're able to not just optimize based on labor or machine, but you may have different other types of business objectives that you want to optimize against. So there's several different types of configurable criteria that can be inputted based on your different business goals. Or it may be a particular customer in which you want to ensure you have on-time delivery for, and you may be able to have some slack in schedule for some other orders that have come in. So to be able to do different prioritizations to help optimize the schedule as well, based on whatever business goals you may have. So any of these goals can be inputted, and then by running the optimized engine, you're able to then even out, and it will suggest to you the proper schedule and plan to go out with. Other things that have to take in consideration is, of course, any setup and changeover time. So we really focus on integrating, all the different changeover times dynamically, and also group those by products to reduce any unnecessary or unproductive time as well. And that's pretty common, especially in today's environment where the orders are coming in typically in a very haphazard fashion, and there's a lot of customization or personalization that's happening on the production line in a discrete environment. Now let's talk about analyzing and simulate. One of the aspects and the benefits of any advanced planning and scheduling solution, but especially here, is being able to understand and calculate the best plan and schedule. So we want to know what, for example, here, we want to show impact of production while still meeting on-time delivery. So here I'm showing different production levels, and I'm showing my line and resources and number of orders. And by showing the impact on that, I'm able to see where I need to make those adjustments. And from that, then, we just do some simulations. So here we can simulate, do multiple simulations against different types of KPIs, and finally determine the best, solution and approach to put into production. And when we talk to our customers in particular, this is the one area that they've been looking for in particular because of the varied demand and because of the increasing number of SKUs. It's become much more difficult to just run an ERP-based or an Excel-based approach and get the optimized solution they're looking for. Lastly, I'd say that, as mentioned before, you want to look for a tool that's natively collaborative. And collaborative is important because it's not just the manufacturing planner or maybe a scheduler or the plant manager, but it may be other stakeholders that can work simultaneously within the tool and suggest different scenarios or input different variables that may have an impact. By doing that, it's very collaborative, and it supports a lot of your lean initiatives that you may have yourself. We get a lot of questions about integration. Of course, any plant scheduling and planning solution needs to be integrated with your ERP solution itself. You may also be doing this from a scheduling and planning standpoint, and you may want to integrate with your LIMS systems if you're doing any sort of quality management as well. We have customers that are doing that from a quality standpoint, and in pharmaceutical, for example, may be doing that within their lab environment where that may be the biggest bottleneck, which would be in the labs itself. But as you can see here, we have certified integration with SAP, with Oracle. We also work very closely with Sage and Microsoft Dynamics, Infor, very large number of ERP solutions we've been certified with and connected with. And we have over 150 already connected today. And this is not a customized approach that's a standard off-the-shelf approach using a visual interface, just a configurator basically to map to the ERP and to ensure that we have the bidirectional data flow between the two systems. Let's talk about some of the results that we've seen in the marketplace by applying an advanced planning and scheduling solution from Dassault Systems. You know, some of the benefits that you want to focus on are these types of benefits. Cycle time reduction. Having an optimized approach to your plant resources, machine, accounting for changeover, labor, and just machine performance really can cut down on the cycle time for production itself. So here we're really talking also about our takt time within the lean concepts. Being able to lower machine setup time. A lot of times machines aren't being set up or are waiting to be set up, maybe because of labor constraints or maybe because of production flow that may be driving a bottleneck is not synchronized properly. So accounting for machine setup time and lowering the machine setup time is important. Overall time savings, waiting for product, waiting for material, not having enough inventory or having too much inventory on hand also is another area that we see significant benefits from customers. And the ROI here, I'd have to say, is a much shorter time frame. Customers that typically have implemented systems in less than 3 months and then achieved an ROI within 1 to 2 months, just by savings on inventory and some of the things that you see here. Other areas of improvement, you see increases just in the capabilities, customer service, and then just productivity of planners and schedulers within operations. So in justifying a tool like this, these are the types of benefits and ROI you want to focus in on if you're looking to sell that to management. Now let me talk about one particular example here. And this particular example is with an aerospace company where they optimized their production introduction and used the tool to optimize production campaigns. So what they wanted to do here is this is really providing digital continuity across engineering and optimization. So starting off, they wanted to virtually design and optimize the final assembly of, in this case, a helicopter. In this case, through digital manufacturing, they wanted to use the digital manufacturing process planning and integrate that with overall planning. So they're using this across their entire operation to identify constraints and then integrating that with their MES systems. So the goal was really to identify the optimized workflow that was driving to the plan of what their expected demand was going to be. So this is all being done before the production line is even built. So they're understanding the best optimal approach. And then also to understand they had to run multi-constraint simulations, knowing that there's an uneven demand up front, where they wanted to get as close as possible to a consistent flow in their production operations at the time of new product introduction when the new orders are coming in. So as you can see here, they really were able to, what they did was they focused on shortening up the ramp-up phase on the production floor itself, as well as shorten the production cycle, and then really start off the production which would be optimized right from the very start. So maybe something you haven't thought of versus having just products coming in, but being able to simulate this up front, even before and optimizing your schedule before you have the plant operations up and running, can provide tremendous amount of benefits depending on your industry. Another customer, which is PPD in the automotive space, also optimized their operations. And in particular, what they did was they really had to deal with a lot of seasonal activity in their production operations. So they wanted to optimize really the capacity of 3 different activities. In this case, they're a provider of automotive components. So it was combined of, sewing, plastic injection, and rubber across 8 plants in roughly 3 countries. And so what they did by applying this is they focused again on some of the benefits, which was reducing the production costs, having a better understanding of the constraints so they could optimize, and being able to have immediate visibility on missing components and optimize their inventory. So in this particular case, we had this customer used the DELMIA Ortham solution to support that overall. Another customer I want to mention is Solvay. Solvay is a provider of materials. They're a chemical company. Their materials are used in planes, cars, across medical devices, etc. So their challenge was really to focus on just improving their overall shop floor performance and making sure that they were meeting on-time deliveries. And they also had a variable demand as well, where they had the seasonal aspects that came in as well, and needed to make sure that the materials were on hand for just-in-time requests at the plant. So they were very much focused on a pull-based approach in their planning and scheduling. And in order to do that, they needed to adopt a different approach and have an advanced planning scheduling solution to support that. Some of the benefits you see down here are real, that happened within a very short amount of time. So they were able to, by looking through some of the scenarios and identifying the actual constraints, they were able to optimize, so they cut down on the changeover processes and in the process of production. And that had a significant improvement just alone in their overall capability to meet demand. A couple other points, I won't go through all of these, but they also had decreased maintenance hours because they were able to line up their maintenance schedule more effectively and deal with scenarios of unplanned maintenance as well. So overall, the capabilities, as you can see here, are very much the same across several different types of industries. Here's another one with a pharmaceutical company in which, in this case, they're looking at optimizing their production of campaigns. So a lot of you do have campaigns that you're running, and being able to optimize those up front versus after the fact or trying to do it on the fly is always a better approach. They were also able to have a much broader, better link between what they had as semi-finished goods orders and finished product, where they needed to line up the proper flow of production. And really the amount of time this one took was around 3 months, and integrated with their MRP within SAP. So also, because it was an approach for a pull-based manufacturing, they had better management of pulling their supplies, significant packaging stock reductions, and significant work-in-progress stock reductions as well. So with all of these different approaches, we've seen some very positive results overall. And what you'll gain through a better lean approach by adopting an advanced planning and scheduling tool with the lean techniques that you have in your operations is really, I kind of boil it down to 5 different key points. Being able to meet target dates. You want to drastically reduce, lead times, reduce inventories. Of course, increase throughput of your assets. And ultimately, by digitizing the process, you're going to ultimately save time in the planning and scheduling aspects as well. So with that, I want to pass it over, and I think we're going to take some questions here.
All right, thanks so much for that, Tom. So a few of you have already submitted questions, so we're going to jump right in. While our presenter is answering your questions, please take a moment to complete the feedback form that appears on the left side of your screen. So the first question is that you mentioned collaboration as part of the tool. What kind of collaboration is available and who is usually involved?
The collaboration is really across not just the manufacturing planner and scheduler. Typically what we see is you have those two people that are involved ultimately, but also being able to bring in the plant manager. And the collaboration really is being able to collaborate on the scenarios as well, and being able to suggest different scenarios that may be impacting the schedule itself. So in that case, you want to have scenarios that are real to life, actually running on the plant floor. So being able to bring in different operators and giving them roles so that they can help in those simulations and help in that what-if analysis is important. So it's a tool that supports multi-users working in that tool, working in the scenarios at different levels of rights, and truly collaborative in that sense. Now, taking that one step further, we also have a tool that brings together all the lean activities. So by doing that, you want to be able to then use that as part of your lean approach that you have maybe up front each shift to identify how we're doing today on schedule. And by bringing that together and using that as a feedback loop into the tool, you're able to get a much more optimized schedule and plan.
All right, the next question comes from a robotics company. So we are currently working on a 1998 platform of SAP with a lot of custom tables and transactions. Can your software be integrated with that?
The tool itself accommodates for some of those idiosyncrasies that we often see with SAP. Of course, a lot of people have some customizations that's in there. We've dealt with different SAP implementations that were, had customization in there. So, depending on where that customization is, it's more than likely we can integrate with that. It is a configurable tool, so it gives us the flexibility to map accordingly. And so we support all the different fields that need to be mapped to an SAP. So regardless of how you customize it, I think that we ought to be able to get at those tables. But that may be something we can follow up on and just validate.
All right. Next question is, how often are the algorithms updated to account for new scenarios, and do you buy per scenario?
Well, you don't buy per scenario. And in terms of the algorithms, we update those algorithms really on a yearly basis. So that's been done, we continuously update those. We look for new ones that may be better. And through our experience in working with customers, we're always feeding that back in. So we run kind of on a yearly cadence to support that, and some of those updates may be valuable for some customers, and some of them may not be. But we're always investing into that and ensuring that those optimization engines are running at their peak level. And as we learn new things, we're also incorporating that in. We've got a lot of customers that might want different KPIs that they'd like to rank on and optimize against that may not already be in the tool, and we can get those added fairly quickly.
All right, thanks for that. And we still have time for a couple more questions. The next one, could you elaborate on what is required to run the capacity leveling simulation?
Sure. To run the capacity leveling simulation, really we just need the initial production plan itself and what is available at a capacity basis on each machine. We can tie that back into the MES so we're getting real-time data that's based in reality of what the capacity is. And that can be updated on a regular basis. So as you recall, we integrate with ERP, but we also, because of the real-time basis nature of it, we also integrate with MES because we need to know that information coming in. So that's another piece. So we need to know that information, obviously, and we can get that from an MES tool itself or other means, maybe just sensors themselves on the plant floor.
All right, Tom. How is real-time data from the floor handled to update the schedule for immediate resource time savings? And can operators provide that input?
Operators can provide that input through their MES, and we can capture that there. Now, we can also update that directly into the tool itself, but that's going to be less real-time, obviously, where we're triggering it. Now, typically, we see companies, kind of rerunning their plan either middle of the day, end of the day, or the beginning of the day, versus in the past, if they've been using ERP only or Excel, it's been done usually at the end of the week. So the real-time nature is really on a daily basis, I would say. But it can also accommodate inputs if we have a significant unplanned downtime or we've got an unplanned maintenance event that affects the schedule. You obviously want to have that updated maybe on the next shift. And so we can gather that information and update it on the next shift so the next shift's ready to go and they understand what needs to be adjusted on their production schedule. And it's typically, you're usually not doing it every second, right? In terms of updating your plant schedule. If you are, you got big problems. So we're typically seeing people doing that on a shift basis or end of the day.
All right. With APS, will we have a push or pull model? And from your perspective, is it better synchronized production orders or operations, flat BOM, for a repetitive production model? And what's the material availability, or what material availability could be considered as a restriction as well?
Well, certainly material availability is considered as a restriction, and with an APS and with this tool, is you're definitely moving yourself to a pull-based model. Most companies want a pull-based model mainly because of the variability in demand and also the unique nature of builds, especially in discrete environments where we may have, a multi-level BOM that requires, different types of materials being on hand at the time. So the tool can also facilitate, inventory and material availability as well. So all of those are taken in consideration. It's another aspect that's a view, frankly, in the tool itself, to know what's my inventory on hand. Do I have not just a labor constraint, but now do I have a material constraint? And do I need to now trigger an order and ensure that the long-term planning or short-term planning for my material availability is in sync with my pull-based manufacturing model?
All right. The next question is, what skill set is required to run ORTEMs?
It's a simple user interface. Getting the tool set up is very, very easy. Manufacturing planner and the scheduler would be involved in that process, but we, skill-wise, it's all configurable. So it's a matter of getting trained on the tool, and we typically do that on site with our customers. And usually within a day, the planner and scheduler are up and running, and they're able to start running simulations and start running the scenarios as well as running the schedule of themselves. So it's a very short ramp-up time.
All right, cool. So can the system run for multi-facility factories or multiple location manufacturing?
The system can run typically for plants that are running their own operations. So as you saw here, we have several companies that have several sites. So they're running those. Now, if they're running multiple sites which are dependent on each other, then we would recommend going to a broader MPS and FNOP type of tool, which we use and we call Quintig within Dassault systems. So it depends on the scenario, on if one's a feeder plant to another, or if that plant is kind of self-contained and running product. But we can do both, but generally speaking, we prefer, for this particular tool, prefer to be within a single plant that's not reliant on other plants within the enterprise.
All right, Tom. How does this system work with a job shop type environment?
Within the job shop environment, you're still able to do the production scheduling as we showed here. You'll be able to identify different types of inventory on hand. You still can level your schedules. As you recall, we take into account labor within one of the constraints. So doing just the essential labor scheduling and scheduling across production with material and inventory, we're able to set that model up itself. Very much similar to, in some cases, a lab environment where we've been applied in pharmaceutical. It's very much kind of a job shop environment as well, because you have different procedures, different tests that are happening. So, whether it's a lab environment or a job shop, the tool can support that.
All right, another question. Where do you find companies are usually gaining the fastest ROI? And maybe expand on that, what kind of companies?
Okay. That depends. That does depend on the type of company. But in general, I would say in discrete manufacturing, the fastest ROI, honestly, has been, a lot of times it's been within inventory, where they are able to level out their inventory, lower their inventory requirements, not have so much buffer built in on hand. The other area that's probably a very close second is just in the overall cycle time, where because you've leveled out the production flow and optimized it so you don't have labor waiting around or you don't have materials that aren't on hand at the right time, the cycle time for production is one of the fastest areas as well, because that once you have that optimized, immediately you see the results, right? And that's probably the top two that I would say. And from a justification, if someone's looking at an ROI to justify an investment into this, I would focus on those two areas as starting points.
All right, and with that, I'm afraid we have run out of time. I'd like to thank Tom Muth and our sponsor, Dassault Systems. As a reminder, if you are registered as a group, please add the names and emails of all in attendance on the exit survey. On behalf of Industry Week, have a productive remainder of the day. Thanks.